Okay, so this last video in this series is a still elimination. So the goal is still to eliminate the variable entirely when you add the equations together. So that didn't change. However, we are going to have to change what we do because these examples require you to change the sign of one equation in order to eliminate a variable when you add the equations together. So in the previous ones, we always had a positive and a negative of the letter that we could eliminate. When you look at these, you can see that you have two positives or two negatives and not one of each. So if I just added this together like I did a while ago, negative 4 and negative 6 would give me negative 10x, and 4 plus 4 would be 8y, and 4 plus 8 would be 12, and I haven't eliminated anything. So that did not help me. I actually made the problem worse. So when you have the same sign, you have to change all of the signs in one so that they can still be added together. And that's okay. As long as you change all of the signs, you haven't changed the actual equation. Think about yesterday or in the previous video when I did this problem. Doing that problem, the signs are all the opposite, but it's the same line. That's how we have a infinite solution, is we have graphed the same line. So that's why changing all of the signs actually doesn't change the line. So what I like to do when I do this is I like to change all of the signs in the top one and rewrite it underneath the second one so that I can still eliminate and have everything lined up really nicely. It's very important when you do this elimination that you stay very neat and tidy. So I have a negative 4. I'm going to change that to a positive 4. I have a positive 4y. I'm going to change that to a negative 4y. And I have a positive 4 on the end, and I'm going to change that constant to a negative 4. So I changed every single sign to plus, minus, minus. Okay? Now, after I rewrite that equation, I'm going to mark that equation out because I'm not going to use it anymore. I'm just going to use this new equation with the new signs. So now when I add these together, negative 6 plus 4 is negative 2x. 4 minus 4 eliminates the y. And 8 minus 4 gives me 4 for my constant. And then I have eliminated the y, which is what I wanted, and I can find out what x is, which it is negative 2. When you divide 4 by negative 2, you get negative 2. Now, when I go to rework this to find y, I'm going to substitute into this equation. Remember, I've marked this one out. I'm not going to use it. So I'm just going to go into this one that I did not change. So I'm going to have negative 6 times negative 2 plus 4y equals 8. Well, that 4 is fancy. Negative 6 minus, or times negative 2 is positive 12. What the world? Negative times negative, positive 12, plus 4y equals 8. And then I'm going to subtract the 12 from the 8. So I get 4y equals negative 4. Divide both sides by 4. Y is negative 1. Negative 4 divided by 4 is negative 1. So my answer for this one is negative 2, negative 1. So it's going to work just like we did it yesterday or in the other video. I don't know why I keep saying yesterday. It's going to work just like in the previous video, except you have to switch the signs first. So just, you got to not let yourself forget to do that. So on this one, I'm going to change all of the signs in this equation and move it down here so that I can add it together and have opposite signs. So I have a negative 2. I'm going to change that to a positive 2. I have a negative 3. I'm going to change that to a positive 3. and then I have a positive 30. I have to change that to a negative 30. And then I'm going to cross that out because I'm not going to use it anymore. So 5 plus 2 is 7x. Negative 3 plus 3 means I eliminate my y's. And 9 minus 30 gives me negative 21. Then if I just divide both sides by 7, I find out that x equals negative 3. Then I'm going to substitute that back in to this equation right here that I haven't touched yet. So I'm going to have 5 times negative 3 minus 3y equals 9. 5 times negative 3 is negative 15. So now I have a two-step equation. Negative 15 minus 3y equals 9. I'm going to add 15. 9 plus 15 is 21. I had to think about that. No, 24. And then when I divide by negative 3, y equals negative 8. So let's just double check that. 9 plus 15, 24, divided by negative 3 is negative 8. So then my answer is negative 3, negative 8. So that's where they cross each other. All right. Let me look at these and see if we have anything crazy. We do have some that are a little crazy. So I'm just going to keep working. But I'm not going to like spell out every single step like I've been doing. I'm just going to change the signs and go. Cross that out. Add these together. That's going to be eliminated. 12 plus 23 is 35. So y equals negative 5. Substitute back in. So I have 8x minus 4 times negative 5 equals 12. 8x plus 20 equals 12. Subtract 20. 8x equals negative 8. Divide by 8. X equals negative 1. So now my solution is negative 1, negative 5. Okay. Next one, I'm just going to change this top one. So I'll have negative x minus 10y equals 7. And then mark that out. Now, this one is going to be a problem because x minus x is 0. 10 minus 10 is 0. Negative 3 plus 7 is 4. So that is not true. Almost just wrote true. So this is no solution. I don't like how that's looking. Oh, that's better. Okay, so these in elimination work really fast because as soon as you see that you've got rid of both your x and your y, if this doesn't equal 0 over here, then it can't be a true statement. And so then it's no solution. All right, 13, going to change this top one. So I'm going to have 9x plus 10y equals 10. And just like on number 12, negative 9 and positive 9 equals 0. Negative 10 and positive 10 equals 0. But negative 6 and positive 10 equal 4. So again, this is not true and it's no solution. All right, number 14. I'm going to rewrite the top one. Negative 3x minus 5y equals negative 29. Mark that out. Add these together. Negative 10 and negative 3 is negative 13x. 5 and negative 5 eliminate the y. Negative 10 and negative 29 is negative 39. Then we're going to just divide by negative 13. Negative 39 divided by negative 13 is positive 3. And you guys be sure and use your calculator if you need to do this. Negative 10 minus 29 divided by, whoops, I left off my negative. Well, I actually wrote the whole thing wrong. Divided by negative 3 is 3. Then we're going to substitute that back in to right here, where we'll have negative 10 times 3 plus 5y equals negative 10, so that we can find y. So this will be negative 30 plus 5y equals negative 10. I'm going to move up here. 5y equals 20. So what I did was negative 10 plus 30 to get 20. So I had to add this to the other side like that. Then we're just going to divide by 5. Y equals 4. So the answer to this one is 3, 4. All right, we got 2 left. Is that right? Oh, wow, we've gone through these quickly. Okay, so on number 15, when you rewrite it, you get negative 2x plus 8y equals negative 2. Then I'm going to add those together. 2 and negative 2 eliminate the x. Negative 7 plus 8 is 1y. Negative 7 plus 8. And then 3 minus 2, also 1. Now, 1 divided by 1 is just 1. So y equals 1 is one of our solutions. I did that with the calculator and stuff so that you guys could see, like, 1 can be the answer. It's not a trick. I know sometimes when they're easy like that, you think, oh, that can't be right. It can be right. All right, so then we will substitute that in like so. So that means we have 2x minus 7 equals 3, because negative 7 times 1 is just negative 7. Add the 7 to the 3, so we have 2x equals 10. Divide both sides by 2, x equals 5. So our answer there is 5, 1. And again, that one seemed really easy because we got these ones right here, which made our problem more simple. You know, smaller the numbers, the easier it is. All right, and finally, I feel like you look at this one and you know everything's going away, right? So if we change this top one, which if they're the same, you guys can see that, right? If I change this top one, it's going to be the exact opposite, so everything eliminates, and you end up with 0 equals 0. And so if 0 equals 0, you're talking about an infinite number of solutions. All right, I know that I went through that a little bit more quickly. If you have questions, please let me know in class.